Now let us see the next topic, correlation and regression. Correlation means covariation of two independent magnitudes or variables is known as correlation. If two variables x and y are related in such a way that increase or decrease in one of them corresponds to increase or decrease in the other, then we say that the variables are positively correlated. The variables are positively correlated. That means if x increases, then value of y also increases. Then in that case it is positively correlated. Or if x decreases, then y also decreases. Then also it is called positively correlated. But when x increases and y decreases, in that case we call negatively correlated. If increase or decrease in one of them corresponds to decrease, that means if x increases, y decreases, then such a data is called as negatively correlated data. That is, x and y are negatively correlated. In the other case as well, that is, when x decreases, y increases. In that case also, x and y are called as negatively correlated. A coefficient of correlation, Pearson's coefficient of correlation. The numerical measure of correlation between two variables x and y is known as Pearson's coefficient of correlation, and the formula to find the coefficient of correlation is R is equal to summation x into y divided by root of summation x square into root of summation y square, where capital X is small x minus x bar and capital Y is small y minus y bar. So this is the formula we use to find the coefficient of correlation for the given data. Always the value of R, the coefficient of correlation, lies between -1 and +1, and if the value of R is exactly equal to plus or -1, then we say x and y are perfectly correlated. And if the value of R is 0, then x and y are non-correlated. That means there is no relation between x and y. Randomly it is distributed. The data is randomly distributed. There is no particular pattern when we have R is equal to 0. Now let us see alternative formula for the correlation coefficient R. R can also be found by using this formula: sigma x square sigma y square minus sigma x minus y square. That is standard deviation of x variable, its square, and the square of the standard deviation with respect to y minus the square of standard deviation with respect to x minus y divided by 2 into sigma x into sigma y, where how do we find the sigma x square? By using the formula summation x square divided by n minus x bar whole square, where n is the number of observations and x bar is the mean of all x values. Similarly, we can find sigma y square by using this formula, and sigma x minus y square can be found by using this formula, where z is nothing but x minus y. This z is also x minus y because the variable is x minus y here. We will learn how do we find all these values while we solve the problems. Now let us see regression. Regression is an estimation of one independent variable in terms of the other. If x and y are correlated, the best fit, that is best fitting straight line in the least square sense, gives reasonably a good relation between x and y. Now let us see what is the equation of regression line of y on x. This is the equation of regression line y on x, where r is the coefficient of correlation and sigma y is the standard deviation with respect to y, sigma x is standard deviation with respect to x variable. As we know, y bar is the average of y values and x bar is the average of x values. Similarly, we can write equation of regression line of x on y. So in the left side we will get x minus x bar, and the right side will have y minus y bar. If it is x on y, if we want the line of regression of x on y, we write this formula, and there is a change in the coefficient also like this. Here we have sigma y by sigma x, here we have sigma x by sigma y. So these are the changes between these two lines. In the previous form, regression lines of regression, the terms, that is the coefficient of x in equation 1, which is given by this, and the coefficient of y in equation 2 given by this, are known as regression coefficients. With the help of coefficients of x and y in both the lines of regression, with the help of coefficients of x and y in the lines of regression, that is coefficient of x in the line of regression of y on x and the coefficient of y from the line of regression of x on y, we can find the coefficient of correlation by using this formula, that is plus or minus root of the product of coefficient of x into coefficient of y, where the sign of r will be positive or negative according as the regression coefficients are positive or negative. It depends on the signs of the regression coefficients. The lines of regression 1 and 2 are also of the form, that is can also be written in this way also. This is line of regression of y on x, and the other line of regression, that is line of regression of x on y, can be written as like this, where capital X is x minus x bar and capital Y is small y minus y bar. This form will be useful to find out the coefficient of correlation by first obtaining the lines of regression, as we have deduced that r is equal to this. That means if in the question they ask first obtain the lines of regression, then find the coefficient of correlation, we can apply these formulae first to find the lines of regression, then find the coefficient of correlation by applying this formula. With the help of coefficient of x from this equation and coefficient of y from this equation, we can find the coefficient of correlation. To compute the coefficient of correlation, we prefer to use the formula. So we prefer to use this formula to find the coefficient of correlation. If x bar and y bar are integers, the computation of r will be with the formula this. That means we use this formula when x bar and y bar are integers. Using this formula, use of this formula will be convenient where capital X and capital Y is given by this. Now let us take up one problem. The question is, compute the coefficient of correlation first, and then the equation of the lines of regression for the given data. So first we need to find coefficient of correlation, that is R. Then we need to obtain equations of lines of regression. You can see here the plural word lines. That means we need to find both the lines, line of regression of x on y as well as line of regression of y on x, because of this plural word lines. Let us use this formula to find the coefficient of correlation R. We need to form a table to find all the requirements in this formula. Let us see how do we form a table. We shall prepare the table showing the columns. So these many columns we require in the table. X column is already given. Y column is also given. We generate the column for Z with the help of this Z is equal to x minus y. We create one new column. Then we find the squares of these three columns x, y, z. Then to find sigma x square, we apply this formula. And to find sigma y square, we apply this formula. And to find sigma x minus y square, we apply this formula. As we said, we need a table. Yes, here is a table. The values of x, the values of y, the values of z, that is by using x minus y. That is 1 minus 9 is minus 8, 2 minus 8 is minus 6, 3 minus 10 is minus 7, and so on. Then square x square column, square this column, you will get this, and square the y column, you get this, square the z column to get this. Add all the column values as we require in the formulae. Then find out the averages, means of x, y, z. Substitute the values from the table for summation x, which is 28, and n is number of observations. Count the number of observations. Here we have 7 observations, so n will be 7. Let us substitute in all these formulae. X bar we got as 4, y bar we got as 11, and z bar we got as minus 7. Now let us use the formula for sigma x square and sigma y square. Substitute the values, summation of x square as 140 in this formula, and x bar as 4 here, and n as 7. Similarly, substitute the requirements of this formula from the table. Then we get the value of sigma x square as 4 and sigma y square as 4. Similarly, we substitute the values of summation z square and summation z bar here. that is the mean of z values that we have found in the previous slide. Therefore, the value of sigma z square will be this. Let us take all these values in the formula for R. So we have used all these values in the formula for R, which we have already seen as equation number 1. If you use the scientific calculator and solve, the approximate value will be 0.93. So this is your coefficient of correlation R. After getting R, then they are asking lines of regression. So thus R is equal to this. Now let us find the lines of regression. Lines of regression are given by, so this is the one line of regression, that is y on x, and other line of regression x on y. By substituting the values of y bar, r, and sigma y, sigma x, and x bar, in this equation also we will substitute all the requirements from the table, and x bar and y bar. After substituting and simplifying, here this 2 and 2 gets cancelled, and here as well it gets cancelled. Further simplification will give you this step. And again further simplification, that is if we multiply this inside this 0.93 with x and with 4, and take this minus 11 to the RHS and simplify. Here as well we multiply inside and take this minus 4 to the RHS. Again if we simplify, we get the lines of regression, that is y on x as this, and line of regression of x on y as this. Here the coefficient of x is 0.93 and the coefficient of y as well 0.93. So these are the coefficients of x and y here. So we found the lines of regression. Next problem, obtain the lines of regression and hence find the coefficient of correlation for the data. In this problem we are finding lines of regression first and then coefficient of correlation. The data of this problem is same as that of the previous problem, but we must find regression lines first and use them to compute coefficient of correlation R. So we first compute x bar, y bar, and denote capital X as this and capital Y as this to form a table which includes these columns. If you find x bar, the value of x bar will be 4 and the value of y bar will be 11. We know how to find x bar, that is summation of x divided by number of observations, and y bar is summation of values of y divided by number of observations. So this is a capital X, which is x minus x bar, x minus x bar. X bar is 4, so we have taken 4 here, and capital Y is y minus y bar. In the place of y bar we have taken 11. This we have already seen in the previous problem also. Here these are the two formulae to find the lines of regression. Let us form a table now which includes x column, that is capital X column, capital Y column, and capital X into Y column, then x square one column and y square another column. So these are the columns in the table. We require the summation of this and summation of this in the formula. Here how we found capital X, x minus x bar, that is x minus 4. If you go on doing x values minus 4, because x bar was 4, that is 1 minus 4. 1 minus 4 is minus 3. 2 minus 4 is minus 2. 3 minus 4 is minus 1. 4 minus 4 will be 0, and so on. Similarly, by using y minus y bar, if you go on subtracting y minus y bar, you get all these values. Now let us use all these values in the formula. Let us substitute here. In the place of summation x into y, we put 26, and in the place of summation x square, we put 28 here. We replace capital Y by y minus y bar and capital X by x minus x bar, and we have substituted the values here to get this 26 by 28. In the other line also, we replace capital X by x minus x bar. X bar is 4 and capital Y by y minus y bar, where y bar is 11. This is our capital Y, and this is our capital X, that is x minus x bar. If we further simplify, we get this, and again if we multiply this inside and again further simplify, we get the lines of regressions as this. We make use of the coefficients of x from this equation and the coefficient of y from this equation to find the coefficient of correlation as so these are the lines of regression, and now we compute R as the geometric mean of the regression coefficients. That is, here is the formula to find the R. R is root of coefficient of x into coefficient of y. As we have already seen, coefficient of x from the first equation is 0.93 and coefficient of y from the second equation is 0.93 as well. So if we simplify this using the calculator, we get 0.93 as the answer. Here the sign of R must be positive. We have taken positive sign because both the regression coefficients are positive. Since both are positive, we have taken here positive sign. Thus R is equal to 0.93. Here is one remark. We can independently compute the value of R in the previous problem by using the formula, this formula, and these are the values which we can substitute from the table. So if we substitute, we get the same answer as 0.93.